So we're going to start this module with an example from an introductory astronomy course taught at Vanderbilt. In this course, the students are mostly non-majors and meet once a week for 3 hours for the lab. They do projects that are short and can be completed by individuals or by pairs of students in a single 3-hour block. You'll hear from the instructor and a couple of students in the lab, and I encourage you to pay attention to what they have to say about student motivation and responsibility in this lab.
So today I'm trying to figure out what spectral type star is most common in our universe. And I'm going about that using this program here actually, SCOPE, which you look at the spectral lines of various star clusters and then you try to match it up with different spectral type, known spectral type stars. And then so you can classify the stars and figure out kind of number based what is the most common in the universe. I think the main thing for me was that, whenever you look up at the stars, they all look very similar. And up until I took astronomy this year and I got into this lab, I didn't realize that every star has its own kind of personality, its own characteristics. And so I got interested in this to see, when I look up how many of these stars are like one type versus the other, and then how, now I can look up and kind of see based on color, oh, this is an O, or oh, that's an M. So that's kind of been a cool transition for me, and so that's why I picked this question.
This is kind of a style that people have called backward faded scaffolding. So you provide a lot of support right away, and then you kind of gradually take away the supports over the course of one lab. So during 1 2 to 3 hour lab period, they first will look at the website that we're going to have them gather data from or harvest data from, and then they get to know it. And then they look at an evidence-based conclusion that we have given to them. And then they say, yes, this is true, or no, this is not true, and why. Then after that, then they start looking at just a data table that's already given to them, and then they make an evidence-based conclusion from that. Then they have to design a procedure in order to get evidence-based conclusions. And then they actually make their own question, a procedure, gather the evidence, and then make the evidence-based conclusion. In this particular lab, there are 12 labs, and 6 of them are this inquiry-based style, where it's the backward faded scaffolding style. After having been trained on how to actually make evidence-based conclusions and create answerable research questions in general, they are creating a poster. And it is really just 9 PowerPoint slides, but it's a poster, and you can see some behind me. And they are going to present it to each other, and they're going to evaluate each other. And so they've just been trained, and over the course of 3 hours, they design a question, gather the evidence, and make their poster. We give them an entire lab period to actually do that. And then they present for about 5 minutes or 10 minutes, and they really start to own it. They really are excited. They're very passionate about what they find. And a lot of times they're like, yeah, I didn't really know that when I first started this. I didn't know anything about galaxies. I didn't know anything about how galaxies might interact. And they start taking that and making it part of what they now understand. So it's really exciting.